going to be good. All right. So, hi, I'm Carly. We're going to talk about brick today. And a whole bunch of, if you go to the next slide, I'll kind of talk about like how the heck we got here to this conversation. I've had a lot of different hats in my life. I started in sort of academia. That's sort of where I went to university is in Canada, and Hamilton is really the center of a lot of masonry research that's paired with the Canada Masonry Design Council. And that's sort of where I did my master's and like started a PhD. Was sort of everyone I did my master's with now works at the Canada Masonry Design Center, or sort of like leaders in the masonry field working on code, which is an important piece to keep in mind as we go through this. Is sort of the sort of what everyone was working on. I was working on funky stuff for like third world development and how to look at masonry differently, and how to sort of optimize and make our systems easier. Notice some weird stuff that I realized is wrong with the slide. But then I shifted to really join the construction community. Loved working with my hands and really understanding how the trades work, how their operations work, how they order materials, how they run into like what they need, looking at the mock-up process, looking at all these other parts of our industry from the trades perspective. But then I shifted to the design perspective for the last 10 years. And in that, I sort of got involved, obviously, with the Zero Net Carbon collaboration for existing smart buildings, to which we're in this webinar. But I came to this through CAHP, which is the Canadian Association of Heritage Professionals, and in particular, our advocacy. So I've done a webinar in the past on kind of all the work that the advocacy committee has done in the past. So if you haven't seen that and you're looking at this webinar and want to know all of the background as to how a lot of us got here, there's a webinar you can dig up. But also that really led us to look at existing buildings is really our main focus in the advocacy committee. And then that really spirals into everything. It's like we have planners, we have engineers, we have architects, we have historians. It's how to look at the built environment and say, like, what do we need to advocate for? How can we really understand what the challenges are to our built environment right now and systematically start to undo them and to work towards solutions? And that led me to sort of join the TCSP, that's part of the Association for Preservation Technology, to really mirror sort of what we were doing in the advocacy committee with sort of that technical grounding and sort of connection to sort of the North American approach of how to bring all of us together in this technical community with a little bit of efficiency as we sort of build this new frontier of our field. And all of this work has led me to sort of dive into material reuse in a really big way. It's now my full-time job. Sort of building the systems to make all of this happen. Next slide. So I'll come from the lens of a whole bunch of CAHP professionals across the industry doing work together. So I wouldn't say like all of this is done through CAHP, but it's a bunch of heritage professionals, but also very like technical APT professionals coming together to build the systems and solutions to make sort of to drive what how we sort of change our field. So a lot of the work that we did within the CAHP Advocacy Committee that you can refer to our last November webinar led us to work on the Ontario Embodied Carbon Toolkit for a good sort of year and a half, really building the systems that showed not just circularity and material reuse, but that reusing the building is sort of the first step, and how to really look at maintenance, how to look at durability, how to look at adaptive reuse, and then figure out, within adaptive reuse, we're doing a lot of material reuse. And then also in the demolition phase, there's a lot of really good materials that we want for all of this adaptive reuse work that we were doing. And we really sort of stepped up to really flesh out our existing systems and pair it with new construction embodied carbon policy that was developing in the city of Toronto. Next slide. And from that, I'd say the words that I did not have in my vocabulary like 5 years ago or even 4 years ago was circularity. We started to have embodied carbon, which is sort of how we worked on the embodied carbon toolkit. But more and more we got to circularity and what that looks like across the whole environment of really understanding the linear economy. If we buy something, we use it, we throw it out. And then there was recycling of sort of how, from a brick perspective, how to take our brick and we crush it and it becomes sort of our fill for roads across the country. And then this real like circular economy that was really sort of jargon we didn't have 4 years ago. And more, we just looked at what we were doing in the restoration field and say, like, material reuse is just the circular economy. We already do this, but we do it within projects. But it was starting to use a new sort of language or vernacular for what we were already doing that we really didn't have before. And that's really been this shift of how to take a bunch of language happening in sustainability and new construction fields and look at what we're doing in the restoration field and understanding that we're talking the same thing, we're just calling it something different. The next slide. And it really, we took a deep dive into the current state of reuse practices. That I will say, my experience was the new construction world showing up to talk circularity material reuse as if it was a brand new thing, that no one did this. It's like brand new to look at because they were looking at it under the lens of steel and of concrete and of like all of these other materials. When we really showed up to the table to say, here's this restoration industry and here's all the things that we reuse every day within our project. And it is part of this conversation. How can we look at what we already do and be this launching point? And in particular, I live in Toronto, where I think we've had the most cranes per capita, like since I was in university. We are knocking stuff down and building stuff up. And I'd say someone outside of ZNCC, there was some perfect webinar that explained, I'd say, the Canadian housing crisis, that I think we need to build as many houses as the US does. And we have a fraction of the population that you do, of to say, like, we are in a housing crisis and like we need density. So stuff is coming down, but we are trying to look at the built environment to say, like, how can we do adaptation? How can we maintain our heritage in all of this? And really, our starting points were adaptive reuse conversations, restoration conversations where we're taking down on a micro scale, we're taking down gables and using that material to do localized restoration on the rest of wall assembly. Like that happens within every project. We're obviously trying to maximize material reuse within projects, take stuff down, repurpose it, rebuild it, put it back into the same building fabric. But then we looked at the broader new construction industry. And really in the big adaptive reuse projects, the engineers were really starting to push the envelope on material reuse, kind of in this like lovely hidden way. That I don't know that anyone coming out of those buildings outside of the design teams like knew how much material reuse was happening within those projects other than the design team, because it was happening within our sort of closed heritage adaptive reuse community versus the circularity discussion happening in the new construction community. And what really changed here in Toronto for me, where the dots started to connect, was one of the heritage restoration architects used one of their great sort of adaptive reuse projects right in downtown Toronto. And they brought it to a ULI event. And it was a circularity ULI event. And they're like just describing a regular restoration job, but using different language, that everything was like circular and like giving it new life and talking about the embodied carbon of the materials, when really they were just restoring windows and like redoing the layout and reusing the structure and doing really just good heritage practice. But using different words meant everyone on that call that was like in the new construction worlds that normally would tune out heritage was paying attention, and it was highlighted and celebrated as like this huge like circular achievement. And it was this real understanding of like, how can we pair this different language and use it as an opportunity and start to push the envelope? So then we started to look at what else we do. That at least in Toronto, we have a lot of facadism. So we have buildings that are either where the exterior walls are being sort of kept in place, like the photo, or the other buildings that were beside this actually had their facades were deconstructed, stored on a contractor's yard, and then reinstated as part of the construction process. And so we looked at, here's this existing process to say this is kind of all that we got to keep as part of heritage. And that was really sort of if you refer to the November webinar, sort of what we wanted to work back to say, like, should more of the building be kept and like be repurposed, and how to write some policy to help highlight, which ones could really fit that adaptive reuse category and not just have a default to facadism. But once we end up here to say we're already salvaging material, we're probably already doing the material testing, we have a spec, we have a contractor, we have scope, where we're doing material reuse already within the project. And there's a whole other rest of the building. Like there's 95% of the rest of the building that we're not grabbing the material for. And how can we look at that? And we've started to have some deconstruction conversations here in Toronto on a very small scale, but it started to be a word that became in our vocabulary. And many in our field would just call it restoration, that we do partial deconstruction all the time in what we do. But it started to say, how can we mirror these languages and worlds together and really do something with it? Next slide. So then it really became like, how do we bridge these worlds? In heritage, in our sort of our CAHP workrooms, we coined embodied carbon preservation as this way to connect the two languages of the new construction world and embodied carbon, and the preservation world of what we were doing. But there really needed to be some uh, challenges that we tackled to make all of this be efficient, that we started to really look at our existing processes with this sort of magnifying glass and say, okay, if any of our processes are going to scale, what are the problems we need to solve? And it really came down to how do we make material reuse easy and not taking up a lot of time and budget and make these materials trusted. And we really took sort of the approach of within our projects, here's our sort of roadmap to trusting the materials that we've developed over time. But then how do we transfer that trust across each other? And it was this core problem that we really set out to solve. Next slide. So the other part of this was how to sort of implement a system in these conversations, one that can transfer the trust, but can really understand like what the new paradigm could be. And we really looked at the conservation plan as the materials that are staying in place to say, here's the materials that are part of the existing building that are going either staying in place or going back into the new development that we're building. And then there's a salvage plan. Here's the materials that we're extracting from a building to go to a new building. And then there's a demo plan as normal. And we're really sort of, the current paradigm is we're stuck either in a heritage conservation practice or a pile of garbage that you're maybe picking some stuff up from. And to say, like, as part of looking at this overall system, we really needed to figure out how we all work together to bridge this gap and to sort of get out of that cycle. Next slide. The other cool stuff that was going on over time, for 10 years, I'd say I personally tracked sort of the general restoration cost of replacing with new brick versus cleaning what you have and putting it back in. And over time, at least in Canada and where we were at, it started to be on par. That more and more, the cost of the materials and the cost of delivery and the cost of all of those things started to be, more expensive, and more, we did a lot more material reuse. Everyone started getting comfortable. The prices started getting more accurate, and close to make it, basically a financial no-brainer for owners to do material reuse. But then there is, I'd say, it's come up on previous 70 webinars. So go to the next slide. Next slide. So the brick receipt machine got invented, and this is from Quebec, and now they are global. So if this piques your interest, like please reach out. We're now sort of partnered in this solution of what this can look like, but it was a way to really make brick reuse even faster and more economical from the contractor's perspective. And in particular, it made it so that this wasn't a heritage conversation, that it was an all brick conversation, that the machine has the ability to clean cement mortar and sort of put that industrial lens on brick cleaning in order to sort of generate material en masse. So if you go to the next slide, and if Nikita presses play, it should, without audio, like show you the machine. So there's a little blade on the left that will take off the mortar that are on the ends of the brick. Then you put the brick on the sort of middle belt. It'll guide it in with lasers and use grinders to take off the sides. And you can sort of, depending on your staff, you can do 100 to 300 bricks an hour. And that's really where, you get an industrial process going on of what that can look like, how you can cycle things through, how to make this really efficient and start to build the scale to make all of this work. The next slide. So if anyone's interested, we have a ton of case studies and ton of data to like actually give numbers. But it was really fun to apply this for both sort of building demolition, but also building restoration. Like especially where we're taking down large amounts of existing skins to like fix the backup wall, fix the waterproofing, fix details, and then we're putting material back. It started to become a real economical solution that could start to sort of drive wider adoption of material reuse. Next slide. So, however, where this machine has been sort of applied en masse, particularly in Europe and as well here, you start having a bunch of material and saying, can I trust it? Can I use it? I still have questions of just like we've generated a bunch of material and it's cheaper, but how do we build the trust? And it keep coming back to, our current standards. We have to test everything. Everything has to meet all of our metrics. And that needed to be tested. To say it was great, we can generate it cost effective. If we have trust in materials, we can use this. But there was still this other part of the system that we needed to tackle, which is what we really want to dive into today. Next one. So to do that, like slide later, um, we've created a reuse collective, as well as a marketplace to move materials between each other. And all of this came from the point of basically putting all of the engineers in a room and saying, how do we trust each other? And how do we need materials to move between each other? That like when they're with us, we trust them. And I trust you and you trust me. And what's the system that we can develop to actually move things between us and transfer that trust? But also how do we start to de-risk this process as an industry? So we sort of our first piece of a reuse collective that's now being sort of applied across other practices was to create a brick squad. So I think the next slide goes into that. Great. So the first step in February, we got all of the brick engineers in Toronto across a wide range of firms, of like small sort of niche heritage firms to like giant international firms, to put everyone in a room. We also pulled in a whole bunch of experts from across the country, but also across the pond, to just talk material reuse. And all of this came together in particular of conversations within CAHP and within our advocacy committee, really basically highlighting the underlying fact that in material reuse, like the best practices for our fields aren't really written down anywhere. There's not a lot of documentation around material reuse, from an engineering, from an architecture, from a trades perspective. And that was really what we are starting point to say, if we all show up to a room, we all agree on our best practices and we write them down, can we start to like incrementally de-risk these processes for all of us? To say if all of us would have made the same call, would have evaluated the wall in the same way, evaluated the material in the same way, sort of felt the same comfort level with putting it into different assembly types, in a new building in the same way, can we write that down? And can that suddenly start to de-risk, from a sort of legal perspective, an insurance perspective, sort of the industry overall? That if all of us would have made the same calls, we can start to sort of have something to build from. But it became very interesting to throw a bunch of experts into the room, say like, this is the problem we're setting out to solve. And we actually solved a lot more. That it was really interesting when you throw different perspectives in the room, and particularly we engaged code professionals. So we brought in the Canada Masonry Design Center, who really saw it from this lens of code and standards, and this bigger picture of the materials, of not just this micro lens of sort of salvaged brick, but saw all brick in general, of here's the brick standards in general, here's where maybe the brick standards fall short or need to change or have, some roadblocks, and how can we look at this. There's also within the Canadian Standards Association, so the Canadian version of ASTM, there's a developing circular construction technical committee that's now launched. And they were also on board to understand that, they generate the standards, but in sort of all of these developing fields, how can they partner with the actual engineers, and sort of practitioners on the field in all of the baby steps along the way to like get us to the standard, and not just sort of like, have everyone twiddling their thumbs waiting for the CSA to magically, generate a standard, down the road. So next. So we did a fun deep dive into everything that exists. And there's some great resources. So I'll go through them quickly. Just know that they're there. If it piques your interest, they're in French and, not French, not English. I would say Belgium. I don't know, like I'm going to Flemish probably. So ChatGPT was a great resource to translate them for your knowledge. But they're really, really great. There's a group called Interreg that has come together to bring together a whole bunch of different countries and really dive into material reuse. And there's a bunch of great resources, sort of coming out of that group. Next slide. So they received about 8 million euros in funding, which like we don't have, but it was how to look at what they've done, and look at what's useful for us and set a roadmap for what we can do. So there are, a whole bunch of different resources that you can actually find in English, including a reclamation audit method, a guidebook on procurement strategies, collection of material sheets of like material by material, sort of across the built environment, that are really good starting points. Next slide. So this is what they look like. And I will say it's a really good introduction to the material, what you should look for, looking at deconstruction, looking at all of the different aspects to consider along the value chain. But we really looked at it from a critical engineering lens that like there was information missing to actually make sort of the trust and code part actionable from what they had put together. Next slide. So that led us to a really lovely standard. So this is the one that was in French and Flemish. Where they really looked at the application of old clay bricks to be used in a veneer system. And this was really where we were able to dissect and dive into what they were doing and really start connecting the dots of how we can look at the existing built environment, understand what wall systems that material is currently in, what wall system it's going into, and start maybe like differentiating the requirements for those materials. That in Canada, we really started to then understand our current brick code is written for a composite wall system. It's meant to be structural. Like here's all of the things we need to like have that brick perform to, when really all of our brick right now is going into a veneer cladding system. So to say, could we just look at the codes and standards from that veneer system, really unpack and say, what's still relevant in our current standard, and maybe what else do we need to dive into? Next slide. So what we did is we really looked at how we evaluate the buildings and what we in the sort of looking to Europe and the use of the brick critique machine and generating a lot of sort of bricks that exist. We had a lot of questions to say, where did they come from? What performance criteria did they have? What is all this other information that as stewards of the buildings sort of during their life cycle, we know exists? It's like, what condition was that wall in? Where on the wall was that material? Was it part of a chimney? Was it part of a foundation? Was it on a completely isolated, perfect condition wall? Knowing that information completely changes the trust dynamic. So we really set out to say, how can we separate out like what we need to know and get it to paper? It's almost like a nice, easy checklist to create a standard evaluation protocol. So it started with what era was the brick in, that at least in Canada, there are very decisive eras that changed sort of the wall construction types and materials and properties. And how can we start to back that up with testing data? And really what this started as 2 years ago was a little bit of a random question to the Canada Masonry Design Center to say, can we visually grade brick? Can we come up with some sort of evaluation system that gets really close to saying like, what bricks do we trust? What bricks are in, grade 1 and grade 6, and really start to use our knowledge sort of with that lens. The other, one back. The other part that we looked at is where we are currently doing brick testing. I'd say we aren't really consistent. And it was to say, can we compare one test on one project to test on another and really bring that information together and, do something with it? A little bit of the answer was no, that we needed to set up a standardized testing protocol for exactly what we're looking at. Do we need to do that within academia to really like flesh out what that can look like? But we also looked at all of the data that all of our projects are generating that just kind of gets lost and sits within our project. And we looked at the opportunity sort of across all of us to be able to bring that data together and really do something with it. We looked to what England has done overall, where they basically have long databases of certain bricks and certain performance criteria that have been very consistent over time. So you at least have a starting expectation of how that material should perform. And the goal is to create that same data here so that eventually our testing protocols can like do some verification and testing to make, to check that your sort of brick performs as expected without having to do the extensive testing that our standards currently require. Next slide. So essentially we've developed basically a new material use pathway to say, where did the bricks come from? And based on everything we know about the bricks, what is suitable for the new use of that brick? And depending on how you want to use that brick, what are the different testing protocols that you do need to meet? And it was really how we could dissect sort of every different use case and say, what's actually important here from a risk perspective? Where is freeze thaw actually like very important? Where is sort of the saturation capacity of that brick really important? Where is this brick just going to go into interiors and landscaping? We don't need to ask any of these questions. But it was how can you set up this really like robust framework and kind of decision-making flowchart to really support all of this and sort of help siphon materials into the buckets that they're best suited for. And then it was how do we rewrite the standard to do all of this? And it was particularly looking at the freeze thaw test. And from conversations with our European counterparts, they were really looking at us to solve freeze thaw and to say, like, what can be the standard that we can apply to brick reuse from a freeze thaw perspective that can really understand what our risk criteria is that could be mass adopted elsewhere, that has less freeze thaw concerns, but freeze thaw is still obviously on the table as part of the standards. And more, we started to dissect through all of the research that was happening at University of McGill, particularly where our bricks were falling short from the current CSA standard. And that the current CSA standard that we have, basically the freeze thaw test that we have to do in Canada is where the brick is under 100% saturation. So like it is fully waterlogged and has to go through 50 freeze thaw cycles. And we all stepped back and said, there really should be very, very few design scenarios where a brick should ever be in that scenario. And so it was working our way back from that to say, okay, what are the design parameters that we can implement around the brick with some guidelines that can really unpack, what does a freeze thaw test need to look like to assess what the risk of that material actually is. And we really started to unpack these questions and really develop a roadmap of testing, of innovation, of how we can really drive where the standard can go that can actually help and sort of supplement our current practices. Next slide. And it really became about trust. So our starting point was our trust checklist that is now what we're currently using between all of us that are generating sort of salvage brick within the salvage plan to sort of, take brick from one engineer that trusts it and get it to another engineer and get it into a building as fast as possible. It was how to sort of develop the system using the contractors with trust at its core, and making sure we're transferring all of this original existing building information and getting it very much attached to the building materials that we're generating. Next slide. So the next steps. So I would say our little working group that we did in February, we came out with a roadmap to rewrite the code, the brick code in Canada, but everything got a little bit bigger. So about a week later, after we did that, the Canada Masonry Design Center basically got awarded a large amount of funding to look at existing buildings in masonry. And really their goal is the support of trade. So I'd say very probably similar to IMI, sort of training masons on the ground. But they also recognized that we really had no design protocols here in Canada from a restoration standpoint in order to train the trades on those practices. And so it was all very much lumped together in a way to look at alterations to existing masonry buildings. So this isn't just mass masonry. It's how to put a door in a CMU wall at Walmart. It can be, all of this ranges of information of how to train the trades, but also train the engineering community of how to do this. They're literally signing the paperwork this week. There was a lot of delays in actually getting the funding and the plan, but it really made sort of everything we dove into in the brick reuse working group able to now extrapolate into a much bigger plan, but also sort of give it support along the way, and sort of a much bigger sort of government supported industry approach. The other part is the CSA has really stepped up to provide us testing. So we're applying for funding right now in order to create a pool of money that basically we can apply to all of our projects, apply our evaluation methods, start doing really consistent scientific testing to then build up this data set that eventually the hope is to become a CSA table and really start compiling all of the testing data across our project. Next slide. And that's how do we efficiently do this? It was sort of like, here's how everyone can come together. And it was this real example of how do we solve the problems that are in front of us and how do we do it efficiently? And so part of that is the next slide is connecting academia, using all of these resources and really connecting them to the industry and the bigger picture and to each other. That a huge part of this deep dive that we've done in the last few years is realizing just how siloed everyone is. That I'll say, at least here in Canada, Master University is diving deep into code. They're paired with the Canada Masonry Design Center. They're looking at all different aspects of materials and really cool stuff. But then Carleton in Ottawa is diving into adaptive reuse. So they have all of this sort of core deconstruction, adaptive reuse, real industry knowledge. And then McGill is doing deep structural testing of existing bricks. And I would say no one's really connected to each other in a really efficient, streamlined manner and efficiently connected to the industry. And that's really where we're kind of getting the starting point by bringing everyone together into one collective space to really understand what everyone is looking at, what they've learned, what's applicable to industry, and really how to drive those solutions forward. So next slide. So coming back to sort of what we're doing, the Brick Squad was our first piece of the Reuse Collective. It really of what we're sort of I'm launching here in Canada to look at a whole bunch of other problems. It was how to get everybody in a room and effectively solve problems and bring industry and educate the industry together with academia and education, and how to really effectively train everyone outside of these little bubble circles is really sort of our way to tackle this. That we're bringing together the core organizations, in particular, sort of our masonry associations, our concrete block associations, sort of like everyone in this masonry circle, along with the academic partners and the design community to these problems collectively together. Next slide. And that's it. So I will say thank you. I wear kind of two hats. All of this came from I would say CAHP professionals in Canada, and as well as partially with the advocacy committee within CAHP. But then a lot of us sort of said, this is just what needs to get done. And we particularly, at least in Canada, most of us that are technical are in CAHP and in APT. And so it was sort of this grounding of the preservation community, but also like how we can look at our existing practices and improve them. Because more people are paying attention to things that used to be in our bubble. So how can we optimize them and take all the lessons learned and start tackling things to get to that efficiency to bring everyone else in at scale?
Oh, hang on. Thank you, Carly. Okay, can you hear me? Okay, great. Thank you, Carly. That was amazing. And let me see if I can turn my camera on if it wants to work. Nope. Okay, well, there's that. Well, all right. Well, anyways, hopefully you can hear me. That was fantastic. Things that we're realizing as we're using this platform is that since this is a webinar platform, we can't chat with people, but you can put your questions in the chat. And then it looks like we do have a couple in there. And so, Carly, before you sign off, if you don't mind answering the one from Shibe, hopefully I said that right. Sorry if I didn't. But their question is, if the same batch of recycled brick has a variation and it is not possible to test the whole batch, kind of similar to new brick, how do you establish the selection criteria over a variety of units?
Yeah, it's a core problem was of why we mapped out sort of our protocols of where we got at this point. I come from a sort of the small restoration space where it's, we're you're plugging in like one or two bricks at a time. And I kind of said, like, I've never tested a brick in my life. It's you look at it, is it good? It's here, it goes back into the wall. And then you go into, you're more rebuilding the structure side of things. Then all of a sudden you need to look at more stuff. And part of what we're doing with the testing protocols that we're setting up is to be able to share the data to understand like this brick type that everyone uses, it's all over the place. Like it is not going to be consistent. You could test out the wazoo and keep it going, and you're never going to have an answer that anyone feels comfortable with. Or guess what? You're going to have a super consistent answer right from the jump. You don't need to do 25 tests. Or if you get something outside of that, maybe keep testing because you have something that might be off. But it was a way to start, at least on ground zero, to start collating the data to then be able to share back amongst the entire community. Instead of having, sort of all of these investments in brick testing that are like hidden within projects, kind of stay within projects. It was like how to start pulling them together really effectively. And at the same time, it was actually just fortuitous. There's a large government project in Canada that's happening where there were 30 different brick types. And they sort of took the scientific approach with our International Research Council to like dive in and look at everything across these 30 brick types to start that understanding of like, test 20 bricks from all different sides of the building. Is the testing consistent? Is it all over the place? Start to understand that from a foundational level. It was the same sort of protocols that we were developing within the Brick Reuse working group that is now the base of our CSA work, so that we can easily share to say, if you know that you have this type of brick, know that like the testing data may be all over the place. Like you may not be able to use that brick in a giant structural wall to your satisfaction, but it could be perfect for like this level of localized repair. If that brick looks and appears and was performing or in its original condition and like perfect shape, you can use it for all these purposes. The other part was to connect sort of all of us as structural engineers that need to meet all these criteria and say, here's all of this material that might not meet our criteria and we can't use it. It became waste. And say, when we know it's good, it's just not good for what we need to use it for. And it was how to efficiently now connect our world with landscaping and interiors and all of the other restoration jobs that might need, bits of that material and don't need it to build a whole new structural wall. When, particularly from a heritage perspective, like so much of the city was built with like a few brick types. And so, depending on what those materials are, it was how to be part of the system and build the system to efficiently get it to those other use cases, especially if you have a volatile brick that you can't use structurally. You say it's all good. It's just we can't use it for what we need to use it for. That's sort of how we took a step to look at this. And I know, I guess to Roy's point, I know the Masonry Society is also looking at sort of an existing building or existing masonry assembly standard. And there's a number of people that are on sort of both committees. But I'd love to connect about sort of what our approach is to tackling this to be really consistent. That's the point of why we're sort of merging a lot of these worlds so that we can get really efficient about how we sort of build this together, given sort of, and also highlight when freeze thaw isn't an issue, how to really unpack what easily works and build the system and where things, matter or don't matter. Then we can do that together. So hopefully Roy grab my email and please send me an email and I'd love to collaborate.
Well, thank you so much, Carly, and for your patience and grace through all the early Demio learning.
Yes,
Yeah,
thank you
I
so
didn't
much.
sign up for my own webinar because I just assumed it was like the standing meeting.
On the plus side, we'll have it recorded. We have everyone's email address, so hopefully, if you signed up via Demio, you should be on the I guess for the next ones that come up, and Carly will make sure that you get the correct link as well. And then we'll also be able to send reminders and all that good stuff. So we super appreciate everyone tuning in and bearing with us. And Carly's email address is in the chat if you have any other questions to follow up on. And aside from that, we will be in touch soon with more updates about our upcoming symposium, which will feature all of the various organizations that are on the ZNC steering committee. So American Institute of Architects, Passive House Accelerator, Architecture 2030, Carbon Leadership Forum, RAIC, as well as ECOMOS and APT. And we have a fantastic slide that we will load into Demio for next time. So you can have that there. So thank you everyone for listening, and we will talk to you soon.
Thanks, everybody.